The next layer outwards that we see from the sun is called the photosphere. And this layer here is is what we see, what we actually see when we look at the sun. And the light from this region actually comes from just a sliver of the surface of the sun. So actually, 1% of the star's radius. That's the light that constitutes what we see when we look at the sun. And because the light that we see from the sun comes from such a small region, this gives the sun a sharp edge. And also here, the temperature is relatively cool. So it went from 10 million at the core to 5,000 at the surface here. So there are some ways that you can actually see the sun. First thing is you're going to use a telescope, or you can see here a telescope, or you can use a binocular. But the first thing is to never look directly at the sun, either with your eyes or through the telescope eyepiece. You're going to have to look at it using an image. So let's see how this works. So using a telescope, you can just put a piece of cardboard around the eyepiece to block the sunlight. And so the sunlight's going to come in through the telescope here, and it's going to cast an image, and you can just point your telescope towards the sun, and if you place a piece of paper in behind the eyepiece, you'll be able to see the sun. Or you can, if you don't have a telescope, you can get binoculars and do the same thing. You can cover one of the lenses, and you can just block the other, and put a piece of paper around the binocular to block the sunlight. And around the free lens, the sun's light is going to pass through, and then you can look in the direction opposite to the sun at a sheet of paper, and you can see an image of the sun on that piece of paper. So why do we see, so this is a bit more detail about why the sun has a sharp edge when you look at it. Even in these pictures here, you would look at the sun and you wouldn't see just a fuzzy ball. You'd see a sharp edge. This is actually what you would see here, the sun there. So the reason why you see a sharp edge is because the light is coming from the sun, but the sun is spherical. So if the sun is traveling towards your eye, the light from the center will travel this distance here, but the light at the top travels a longer distance. And because the light travels a longer distance at the top, that means that more of it gets absorbed, so it looks darker. Which is why at the center here, it looks nice and bright, but at the rim here, it looks darker because the light is actually passing through more gases in these regions. So it looks darker. So this is what gives the sun its thin edge. And so here it is. This is a picture of the sun where you can see clearly that the sun has an edge here. Some other properties of the sun. The most abundant gas in the sun are going to be hydrogen and helium. You can see that 92% hydrogen, and the next abundant is going to be helium. And the sun also emits an absorption spectrum. The reason why is because all of the heat or energy that comes from the sun has to pass through the surface. And as it passes through the surface gases absorb most of the light, or absorb some sections of that light. So what you get is the light from the inside, but with some gaps or some missing parts. So you get an absorption spectrum. So we just saw the surface of the sun. That was a photosphere. So you can see it here. This is the very edge of the sun. That's what we just talked about. Now we're going to look at the layers above the sun, or the sun's atmosphere. And it's broken down into two pieces. And the region we're going to look at first is going to be this layer of atmosphere that's just above the surface of the sun, and that's called the chromosphere. And the reason why it's called the chromosphere is that when you look at it during an eclipse, so this is from the lower part of the sun's atmosphere, so this is above the sun itself, but in the lower regions, in the space above it. So this region here has a low density hydrogen gas. And because of that, you can see here that that gas creates an atmosphere of a red ring around the sun, a thin red ring around the sun. And so we call that region the chromosphere. And this region emits mostly in the UV light. as this image shows you here. So this looks like you're actually looking at the sun using visible light, but if you look at the spectrum, you're looking at it using UV light here. And this region is the coolest region of the sun. It goes down to about 4,000 kelvins. And so here's a picture of the chromosphere again. It's this thin ring above the edge of the sun, or above its in the lower parts of its atmosphere. This thin red ring. So chromo meaning color, or for its red color. So here, this is an actual image taken from Earth. I'm not sure where this is here, but you can see there's some structures on the ground. And this camera, with some special kind of exposure, was able to get a picture of that thin red ring around the sun, or the chromosphere. And so this is what actually it looks like within that thin red ring. What you notice is that there's like these waves or fields or spikes that are kind of like fields of grass that are waving in that region. So since they look like spikes, we call those things spicules. So you find these spicules in the chromosphere. And this is in the lower atmosphere of the sun. And again, these look like fields of grass that are blowing in the wind. And you can see the spicules again here. These are just spikes. Now the layer above the chromosphere, so you can see again, so this is the skin of the sun, that's the photosphere, and the thin layer, the thin red ring above that, that's the chromosphere. And now we're going to look at this other region, this upper part of the sun's atmosphere, and that's called the corona. And when you see you can see the corona also with the chromosphere. You can see them both during an eclipse. So you can see here, this is the sun during an eclipse. So the sun is completely blocked, and you're able to see this crown above the sun, or these rays here. And that crown is called the corona. And the amazing thing that you find here is that the corona is actually hotter than the surface of the sun. The surface of the sun was at 5,000 kelvins over here. So here that was about 5,000 kelvins. And in these regions here, it jumps to 3 million kelvins. We don't know why this happens, but because it's so hot here, you have you don't have a gas anymore, but you have a plasma. Because an atom, whenever it's too hot, so this is a hydrogen atom here, hydrogen gas. When it's too hot, it's broken up into the constituent pieces to make a plasma. And this region also, since it's so hot, it emits its own light. And here, this is an image that shows you both objects during an eclipse. So you can see the eclipse here, and so you can see the corona during the eclipse. But before the eclipse, you can see the chromosphere, that thin red ring in the sun's lower atmosphere.